So welcome everybody, and let's get started. My name is Noam Lorberbaum. I'm a senior engineering manager at Adobe. A few years ago I started the current Document Cloud Core security team that I've been managing since then, and we're in charge of secure product lifecycle in 60 engineering scrum teams.
And I'm Keith Mashinter, senior computer scientist at Document Cloud. I've worked on a variety of both front-end and back-end technologies with systems architecture and programming, and some contributions to open source projects like Apache Web Server, Tomcat, and Facebook Jest, for example.
And in this talk, we're gonna show how we build layers of security design patterns into the architecture of Acrobat Web, the current web application of Document Cloud. Everyone wants to improve their security. At the same time, we all need to put a lot of resources into our business requirements, so we need to do security in the most cost-effective way. And this is exactly what this talk is going to be about. And at the end, there'll be some tools and methodologies that you'll be able to take and leverage in your own organizations. So we're going to talk a lot about layers, and therefore included some onions. It was Keith's idea. We're going to talk about the new architecture of this web application that Keith would cover. And of course, we're going to talk also about security-related processes, because as we all know, security is not just an end product, it's a whole process as well. This is a screenshot of the web application homepage where users can upload documents to the cloud and preview them. They can perform certain operations on those documents, such as create and export PDF files to convert between file formats, or combine and organize PDF and files and pages. We also put a lot of emphasis on collaborations. Users can share documents, they can review documents and share comments, and they can sign agreements in document workflows. We didn't start from scratch, as it is in many cases. There was a legacy application that existed before, and that's a quick look at the architecture. Starting from the back end, we have shared cloud, where user data is stored in files, and then there are certain heavy lifting operations, workers, that can be performed on those documents, such as the file conversion operations that I mentioned before. In front of shared cloud, we had a Django-based Python application that takes requests from the various clients and sends those to shared cloud, and then asynchronously take the response from shared cloud and send that back to the clients. One point about this Python application, it was written in Python 2, and the Python 2 end of life was one of the motivations for this project. In front of that Python application, we had an AWS CloudFront CDN talking to various clients, my mobile, desktop, and web clients, all using the same APIs. We'll focus on the web application. Another point to pay attention here is that all static and dynamic content was flowing through the same path of this architecture, and Keith is going to talk a lot more about that in his description of the new architecture. Being a classic web application, it had the classic vulnerabilities that we wanted to address in the new architecture and the redesign. Before we start talking and peeling the layers of the application architecture itself, we need to understand the framework Adobe applies to all software development and security. Our goal, and pretty much everybody else's, the security, privacy, and availability of our customer data. The strategy Adobe applies in order to achieve that goal is the Adobe Common Control Framework. We analyzed the criteria for a dozen industry most commonly used security standard and certification for cloud-based businesses. We focused on industry standards such as PCI, FedRAMP, and SOC, and then regulatory compliances like HIPAA and GDPR. We rationalized over 1,350 different requirements down to internal Adobe controls, and then we applied those controls consistently across all product and service development in a company. We aligned all product development with those criteria, which allowed us to then use common controls across multiple products and services. It means we can implement common components once and then utilize them again and again in a cost-effective way. It also means that once we implement those common components, we know that they're implemented right everywhere. The approach we took and the implementation of it consists of two main parts. One starts from the physical layer and goes up. Those include security processes and compliance controls for ops teams and infrastructure teams that involve asset and configuration management, network operations, incident response, and things like that. The other part starts from the application layer and goes down. Those include tools, processes, and activities related to secure product lifecycle, such as static and dynamic code analysis, pen testing, and things like that. The whole process is continuous in multiple ways. There are some processes that we are applying on a regular basis, such as control reviews of certain operations like, sorry, I'm blanked on this. Periodic compliance reviews of automated auditing and compliance controls, such as access to production system vulnerabilities and firewall rules. And then, in addition to that, we also review our internal controls on a regular basis. And finally, whenever the external standards also change or we end support for new ones, we of course need to update the common control framework as well. Adobe made this common control framework an open source, and version 2.0 became available at the end of last year. You can download it from this URL at the bottom of the screen. Let's take now a look at a couple of examples for such common components that are used across the company and also in Acrobat Web, and Keith will talk later about how we integrate those. So one place which is a good start to start building architecture of security systems is the identity system. And the Adobe Identity Management System, IMS, is an authentication and authorization service that is controlling access to all Adobe resources. It's the Adobe implementation of OAuth 2.0. It includes UI component for user sign up and sign in, as well as admin tools for enterprise customers to manage licenses within their own organizations. It also supports multiple account types, such as Adobe IDs for individual and enterprise customers, and it also supports authentication between services. Pretty much every Adobe services integrate with the IMS in order to allow their users to log in and access protected services. The Common Control Framework also determines how the identity data is stored internally, as it is for such sensitive information. One of the earliest examples for common infrastructure used across multiple services is shared cloud, which I mentioned in the beginning. It's a platform that's used by many services in both Creative Cloud and Document Cloud, supporting user data stored in files with multiple levels of redundancies based on AWS S3 buckets with file versioning, encryption, and virus scan. and also multiple variations of jobs that can be performed in a scalable manner, excuse me, asynchronously on those documents, like the file conversion format that I mentioned before. It supports multi-level key value data storage based on MongoDB, HTTP APIs and event notifications for internal services such as data search and data synchronization. Security is based on user context isolation, such that one user cannot access another user data, and the whole platform is PCI compliant, so that all the services built upon it are compliant as well, if necessary. One of the most recent additions to a common platform is Ethos. This is a container-based platform developed by a centralized team that create those base container with secure by default configurations. They also upload common libraries and test those and keep those up to date in a centralized way. And it is supporting CI/CD pipeline based on Jenkins, which goes all the way from a GitHub pull request with hooks for automatic processes such as static code analysis or manual code reviews and deployment approvals. It goes all the way down to support multi-cloud clusters such as dev, stage, and production. And it's based on Docker. Currently, we had also support for Kubernetes. Keith would now show how we leverage those different components and the architecture of the new web application.
Thank you, Noam. So in the past, we had, as Noam described, an architecture that was based more on classic front and back end technologies mixed together, which was typical for prior decades of web development. But for Acrobat Web, the new project, we sought to separate those a little more concerns so we could address them and focus them individually. So the client side became standardized on React-based components, and also with a bit of Nginx mixed in to support dynamic or deep links, I should say, to content that doesn't actually exist as static files. Meanwhile, the more dynamic services were done with Spring-based Java frameworks that were actually based on structures inherited and used across Adobe. So another aspect of this was we moved to leverage more build and deployment standards at Adobe, which is called Project Ethos. So it's a suite of different system components for that build and deploy process that we can now reuse across the company, rather than some of the prior specific service and deployment situations we had in Document Cloud itself. So this divide and conquer scenario helps us focus our energy on solving client problems versus service problems, and offloads a lot of the general build and deployment security problems to Project Ethos, to other teams, so that the application developers can focus more on the applications themselves. So now that we've got this highlight, let's peel the onion a little more into the different layers. So starting from the front end, this top high layer is basically public static content. There's no PHP, there's no custom coding of that level. It's really configuration instead of coding. So the content delivery network, of course, offloads a lot of the content. It enforces HTTPS, and it uses some shared tokens to ensure that traffic is progressing through the CDN rather than someone trying to come directly at the Nginx service or the S3 web-enabled buckets. So now as we drill further, let's start from the client and go through the CDN, which has the initial page rendering. And so that's just static HTML that's optimized to deliver to the client. Then Nginx has a content security policy, and the S3 buckets are the final stage here where most of the content is delivered. So there's only a small fraction of the initial web page loads of HTML that are from Nginx, because it needs to give some support for that. and for deep links, as I said. And then the majority of contributing content or other assets are loaded more directly from S3, still through the CDN. And note the entire top half here is, again, driven by configuration, not custom code, so that really shrinks the attack surface. And of course, as the client loads all this static content, it then needs to call back and actually check for user identity and get associated content from actual storage. So this goes through an API gateway, and again, this is a project that's offloaded from our independent application teams to common Adobe teams for the protection mechanisms there. So that helps protect and auto-scale the underlying services we actually have, which in turn then connect back to the shared cloud that Noam mentioned before. So again, this embodies various common security principles, and some of which, those in yellow at the bottom, we'll delve into a little more in these coming slides. So now we'll split more the top and bottom halves of this to investigate. Oh, okay, some slides got out of order somehow. So we talked before about the CDN. Now we'll talk a little bit about the path to Nginx, which has elastic load balancers in place to protect and auto-scale the underlying services. In this case, it's really Nginx as a service, again, just with configuration, not really much custom logic. Then Nginx itself takes on many roles related to security. It participates in the content protection by making sure we separate development stage and prod areas so that no one in production can see what's happening in the dev or stage areas that are internal. It supports virtual paths, as I said, that don't exist. And this is so we can say things like go to a review, and then we can even have parameters that indicate, of course, what document you're reviewing. And there's protections there as well against certain URI patterns that are expected, rather than someone trying to hack a URI that we shouldn't support. So further to that, Nginx also controls the content security policy for the site, both the homepage default and all the deep links to more specific application services. So these are as specific as possible to make sure we're whitelisting appropriately and limiting both the kinds of actions we let the browser take and the different sites it takes those actions upon. We actually had to spend a lot of time with other groups at Adobe with the content security policy because we were a bit ahead of the game and we had to work with them to make them understand that we were using this, and that if they changed their infrastructure, the hosts that they were involved in or they were using or the protocols they were using, that could impact us. And then there's a range of typical HTTP security headers that Nginx also drives. And finally, we load the rest of the content from the S3 buckets to drive the single page web app. So once the static content is loaded, we load that into React, and React itself provides certain mechanisms to protect the application by default, where HTML, JavaScript, and so on is escaped appropriately, and you have to use special rules to do something outside the norm. Now, going through the service side of the application, to load dynamic content, we have the Adobe I/O gateway, which helps decrypt and manage the IMS OAuth token, essentially. It also provides some rate limiting at this level in a coarse-grained way to protect the back-end services. Again, offloading those aspects from the individual service developers. Going back to the service, the gateway provides a signed token so that underlying services can validate that the traffic came through the expected path to them. And going back to the whole onion again, putting both sides together, you may wonder how we keep it fresh. How do we make sure that changes to application infrastructure and the application changes themselves don't degrade the security over time? Well, part of what we do for that involves an internal project, Adobe Relay, which is an API and UI testing framework. There are many other open source tools that you could use for this as well, but it's essentially a live, ongoing monitoring, synthetic monitoring tool that continues to monitor our site for the expected positive and negative outcomes. So after this internal compliance monitoring aspects, I'll defer back to Noam for some external compliance considerations.
Thank you, Keith. So we had multiple compliances supported by the legacy application that I mentioned in the beginning. During this project, we needed to add support for GDPR, and again, following the Common Control Framework, we used global Adobe libraries to do that. In addition to integrate them with our software application, we needed to change our content security policy so that they could upload and run. Another part which is important of every software development lifecycle is tracking vulnerabilities in third-party library. At Document Cloud, it's mandatory for all components to integrate with that tracking system so that we can automatically detect vulnerabilities in every build and block it from deployment for production if necessary based on it. Pen testing is another important part of secure product lifecycle. We do both internal, external, whether it's part of the release cycle or is determined by compliance like PCI. And in this case, Bishop Fox was the external pen testing firm and couldn't find any serious issues with this application, to quote from their final release. About the application, it conforms to security best practices of modern web application. It was a great confirmation for us that the methodology we used was actually successful. To summarize, we applied many security design principles to the architecture, implementation, and design of Acrobat Web. We followed security best practices in processes related to secure product lifecycle and compliance control that are part of Adobe's Common Control Framework. And to summarize, we achieved the goal that we wanted in a cost-effective way to improve the security. And when sliced and layered carefully, an onion is nothing to cry about and can definitely be super useful. Thank you, everybody. If you have any questions, please don't hesitate to send them to us or find us during the rest of this conference. And by the way, we're hiring, so by all means, if you're interested, come talk to me.
Thank you.